So, as stated, since we derived the quadratic formula the two different ways, you are now welcome to use that quadratic formula. And we will see some examples on how to do this. On example number 6, it says solve the equation by applying the quadratic formula. First of all, it is important to be able to write your quadratic equation in the form ax squared plus bx plus c equals 0. The standard or general form for any quadratic equation. Now, in example number 60, our variable is m, and so instead of having x's, we're going to have m's. But we still need to get this organized so that we can apply our quadratic formula. The first thing to do that is to run the m through, and so we'll have m squared plus 10m equals a negative 34. Then we will add 34 to both sides of our equation, and that will give us m squared plus 10m plus 34 equals 0. Now we need to figure out what are going to be the a values, the b values, and the c values that are going to go into our quadratic formula. The a value is the coefficient of the leading term, and so a will be equal to 1. B is the coefficient of the linear term, the coefficient of m in this case. That's going to be 10, and C will be equal to positive 34. So when we go to solve our equation now using our quadratic formula, and if you want to look at the purple box above, the quadratic formula says our variable that we're solving for, m in this case, is equal to a negative b, so that will be negative 10 plus or minus the square root of the b value squared. I'll write it out for this one. 10 squared minus 4 times the a value of 1 times the c value of positive 34. Now all of this is going to be divided by 2 times the a value. Now it's a matter of getting all of this simplified. We need to work underneath the radical and get all that mess simplified first. Because of the fact that we have terms here, the square and the square root do not knock each other out. That is illegal. Okay? So don't be trying to do that. The way that we are going to need to tackle this is we'll bring over the negative 10 and the plus or minus symbol. Then we'll have the square root of, we'll figure out what goes underneath there, and 2 times 1 in the denominator is still just going to be 2. Now, underneath our radical here, let me kind of come over here and let me just say that 10 squared is 100. Here we have minus 4 times 1 times 34. That is going to be 136. And so when you combine the 100 minus 136, what we get underneath the radical is a negative 36. Now we know how to tackle that. That is going to be I times the square root of 36, or 6i. So let's write the whole thing here. M is equal to negative 10 plus or minus 6i all over 2. Now you need to reduce if possible, and you can't just reduce a couple of these places. You don't just want to say like the 6 and the 2 reduce. You can't just reduce there unless you can, and we can on this one, reduce all 3 places. Okay? Another way to think about this, let me move that stuff out of the way there. Another way to think about this is, and essentially what you should do is factor out that common factor of 2 in the numerator, write the leftovers. -5 plus and minus 6i, and then that's all over 2. Now what we should do is reduce the 2's. So our final solutions for m are -5 plus or minus 6i. Now, writing that as a solution set, I would just recopy that. -5 plus and minus 6i. You might be asked to expand that out a little bit, and so if you have -5 plus 6i, that's one solution. Our second solution is -5 minus 6i. It's complex conjugate.